So good morning, good afternoon, or good evening. This is the Antrea community meeting, and today is Tuesday, April the 12th. Oh, of course, for some of you, it will be still Monday, April the 11th. For today, as you can already see on the screen, we have a very interesting presentation from Chan about a proposal for traffic control capacity, and very interested to hear about it. So without waiting, please, Chan, go ahead.
Okay, thank you, Salvatore. And thanks everyone for joining the meeting. And I'm glad to have the opportunity to present the proposal for traffic control capacity. Let's first talk about the motivation and the requirements. We want to enable users to monitor network traffic passing in or out of a set of ports for several scenarios. For example, when troubleshooting, if we want to see what traffic a port receives and sends, currently the common way is requires you have TCP dump installed on the nodes, and you have the privilege to log in the node and run the command to capture specific interfaces. And you will need to know the mapping between the nodes, between the ports and the network interfaces it uses. Another way is that you need to run a daemon set which have a host network daemon set, a daemon set with a host network mode ports, and you need to run that port on specific node, and still you need the privilege to capture the traffic from specific interfaces. So it's not quite easy for troubleshooting. So one use case we think is that if we can mirror the traffic of ports to specific destination, then it will be quite easy to debug such network issues. And another use case is for analysts. We have an issue from user. It requires that we can mirror traffic of specific ports to a destination via a tunnel. The issue requires a VXLAN tunnel. The traffic can be mirrored to a destination via a VXLAN tunnel. And I think the use case can be more, that we can use any kind of tunnel, even for using the ER-span protocol to mirror the traffic. And another use case is we want to enable users to deploy their own network protections via mechanisms such as DPI, or just use a traditional IPS software for ports with fine-grained control over network traffic. Today, there is no way to deploy a network protection mechanism to intercept the east-west traffic. Maybe you could deploy such software or hardware at the edge node of your network, but you cannot intercept the in-cluster traffic. So it would be great if we can provide such capacity. And the third is that, as mentioned above, if we don't have this capacity, user can only intercept north-south traffic, but not east and west traffic. So we propose to add a traffic control API using related NRD. And the traffic control API accepts clients' request about the desired behavior from users. to control the port traffic with open flow rules. The API is designed to be generic, providing a mechanism to specify the ports to specify the ports whose traffic should be selected, and the direction of the traffic, and whether the traffic should be mirrored or be redirected, and the destination to redirect or mirror the traffic. In the future, we can also provide other options. For example, the protocols of the traffic we are interested in, and maybe the port number of the traffic, or even the IP range of the traffic. And to support, depending on the different use cases, we need to support different kinds of destination. For one use case I mentioned, the issue requires a VXLAN tunnel that is created on each node. So one possible traffic destination is a VXLAN tunnel, and we can also support other tunnel types and even the ER-span tunnel. We can also support a local port for the scenario that the network analyzer is running on each node directly. So we can just create an open switch internal port and redirect the traffic to that port. Then the network analyzer could listen to the internal port directly. And the port can also be a physical NIC or a WSPL if the application is running in another network namespace. So for port traffic, port kind of the traffic destination of port kind, we have two attributes. One indicate whether this is an internal OS internal port. When it is true, it means that we need to create the port, and when it is missing, otherwise the port must already exist. For example, the port is a physical NIC or is a user-created OS device. And the peer name is used to represent the name of the peer device from which the traffic will be sent back to OS. It should only be set for redirect action. For mirror action, this is not needed because we only need to mirror the traffic to the traffic destination. But for redirect action, we need to, because there's no copy, the traffic is directly redirected to the traffic destination. And after a network firewall process it, it may drop it, or it may allow it. So it will need to send the traffic back to the pipeline after it process it. So we need to know which device it will come back from. So that's the purpose of this field. And for remote remote network analyzers, we provide two kinds of destination. One is via the normal tunnel. So it could be VXLAN, GNU, and GRE, maybe even STT. And we need user to provide the remote IP of the tunnel and the ID of the tunnel. Then we will create a tunnel device based on this opportunity and these attributes. And for some well-known traffic mirror protocol, we can also support it. For example, for ER-span tunnels, we provide a specific type for its arguments. For example, the remote IP tunnel and the version of protocol. The other three fields are the ER-span tunnel specific.
Chen, I have some questions here.
Yeah.
So for port destination, do you think it's possible we can have some other solution to pre-create the port? So here we don't need to automatically create the port triggered by the traffic control policy.
Yeah, in this proposal, both scenarios are supported. If users don't want to create their own port, meaning that they don't want to deal with anything related to OpenWSwitch, otherwise they need to mount OpenWSwitch database and the socket, and they need to manage OpenWSwitch. So that's one scenario. So we provide this internal property. You can set it to true, then we will create the port. But for some existing interfaces you mentioned, user can pre-create them, and we will only attach them to OpenWSwitch. For example, user can create a WES device or just leverage a physical NIC directly. Then our code will be responsible for attaching this device to OpenWSwitch so that it can receive the traffic. Is the latter your case?
So you mean so how that device is specified by it's defined by name?
Yes, this is a common attribute of all traffic destination. It basically means the port name in OpenWSwitch. So if you have created a virtual device, and you can just put the name of the device here and specify internal as false.
Okay, I just feel it's a little somewhat straightforward to follow. But I think the other thing that I think it might be possible if later you have if you have some matching criteria, probably it's possible multiple traffic control policy can share one port, right?
Yeah. But that requires that the destination with same name should have same properties. For example, you cannot create one name with internal set to true, another traffic control policy using the same name, but it is a VXLAN tunnel traffic destination. That will not be supported. If they have same properties, that
yeah,
is
I just mean in that case, seems it's easier to understand if you say the port must be pre-created. Then in the traffic control policy, I just give you a OS port name.
So you mean changing the description and the name of the fields to indicate that it should be?
No, actually, I was thinking, should we say the port must be pre-created? That's my question.
But that may be not convenient for other users.
Yeah, I got a mean for my major issue here, like if you have multiple ports share one port, it's a little confusing and probably easy to make a mistake, since it's not explicit. It's no way to explicitly say I want to share the port, right? So
I can think of one use case of in Kubernetes that you can create a host path volume, and the host path volume can be type of directory and file, and or even socket file, and different ports can use same host path volume. But if you create one volume in one port, saying this volume should be directory, and in another port you say this port should be a file, then they will have same situation, they conflict. So when designing this, I also think about that if we want to avoid such conflict, we could create a separate traffic destination CRD so that we can refer to this destination and share it. But I thought it may make the API more complex. So I just use inline structure as the volume mount.
Okay, sure, I got your point. Probably let me also think about this. At least I feel probably we should think about how to restructure the fields a little. I think it's a little, at least it's not very straightforward for me to understand. Another question for tunnel. What does tunnel ID mean?
It just means the when ID. This is a generic
I see.
in Open with Switch. Yeah, in different protocol, it means different concept.
Okay, and you're saying we will automatically create one tunnel port?
Yes.
Okay.
The point of such properties is to prevent users having to operating Open with Switch directly. Otherwise, user have to create another port and mount the same database and socket in their port and manage Open with Switch.
Okay. Yeah, I got it.
Yeah.
Yes,
as you can
that's
see,
my point.
yeah, as you can see from this issue, what they do is that they manage the same Open with Switch bridge, and I think that may be too complex or maybe error prone for users. And the requirement is actually simple. If we know the destination, we can create it directly, not have to be done by users.
Okay. Actually, I originally was thinking another way that you can have I'm not sure it's appropriate way or not, but in theory, you can also have a config map or something to define what the port you want to create.
Yeah, that's one way. But I also discussed this with Hongliang and Wenqi. That's actually my original proposal. But I feel if we, I was not thinking about config map. I was thinking about the configuration of Antrea agent. But that when we user want to use it, user will need to configure the config map and restart Antrea agent. It's a little different from config map describing the tunnel destination or a config map for all possible traffic destination. But I think this mode should be a little more friendly to users. They can describe all desired behavior in a single API, not something in a config map, something other things in a CRD.
Sure.
But we could discuss.
Yeah, I got that. Again, I think my only problem that if later we think this policy will be like a circular policy, you can have many policies and with different matching rules. But share one port, then it's become a little, I don't know. At least I feel it's probably not very straightforward to track what the share the port. For probably let me think about that, and then we can do offline.
Okay. And then I have two examples of how the resource should be configured and what impact it will have for traffic, for port traffic. For example, we have two ports. Originally, they communicate with each other directly. If we want to monitor the traffic between them, we could create a traffic control object, and we use port selector to select these ports and with direction specified to both. And the action is mirror, means that we want to mirror the traffic. And the destination is a GRE tunnel with remote IP set to this IP address. Then after this resource is created in the cluster, we will create a GRE tunnel on each node on the bridge of each node. And we will install some OpenFlow rules to copy the traffic and send it via the GRE tunnel so that the network analyzer running on this remote node can receive the traffic between these ports. And another scenario is redirect. Port 1 and port 2 talk to each other directly or previously. And after we create this traffic control object, this is redirect web app, and we use port selector to choose these ports, and the action is redirect, and the destination is local ports. One port, the receiving port is named firewall 0, and internal set to true means we need to create this this port as the OS internal port. And we will also create another port, OS internal port, named firewall 1. And then user could deploy network firewall in line mode, meaning that it could receive traffic from one interface and decide whether it wants to drop it. If it drop it, the traffic will not send back to the pipeline. If it allows it, it will send the original packet back to OS pipeline while another interfaces. This is a common mode used by several traditional IPS softwares such as Snort and Suricata. And after this is created, the traffic will first be redirected to this device and received by the network firewall. And then if it allows it, it will send the traffic back to the bridge and redirect it to its original destination. And about the implementation, the roof workflow is like such. User will create a traffic control CR via the API, and the Antrea agent will watch the traffic control API and guess the creation event. After that, Antrea agent will handle the traffic control resource. It will create or update the port or tunnel destination if it does not exist or if it changes. And it will filter ports running on its own node based on the specified label selectors and get their OpenFlow port IDs. Then it will call OpenFlow interfaces to install or uninstall rules which mirrors or redirects traffic of the selected ports. And for data plane implementation, for mirroring, we have two choices. One is leveraging the OpenWSwitch mirror function directly. However, it is port-based. So, for example, in this example, it creates a mirror object and specifying traffic entering Ether 0 and Ether 1, or coming from Ether 0 and Ether 1 will be mirrored to Ether 2. As you can see from the arguments, there's no way to specify which protocol to mirror, and port number is not supported. So if we want to have fine-grained control over the capacity, then this way cannot meet our requirement. And we can also have flow-based mirroring, means that we just update the OpenFlow rules to output the traffic we are interested in to one more destination. So the benefits of such approach is that we can filter traffic based on protocol, port, and IP addresses. And because there is no native support for traffic redirecting, if we use flow-based mirroring, we can unify the approach for mirroring and redirecting. The traffic classifying code will be shared. The only difference between these actions is that how the OpenFlow action of their corresponding for the corresponding traffic control APIs objects. So currently, I think this approach is more suitable. And I have a simple demo about the mirroring action. Can you see my console?
Yeah, I can see it.
Yes.
Okay. So currently I have a cluster, and I want to mirror traffic between, let me see, this one, between this port and this port. They are running on same node. Both are BM01. So this is east-west traffic. And I want to get the traffic mirrored to another node via a GRE tunnel. So I have pre-created the tunnel. Maybe let me share it here. Oh, I created a VXLAN tunnel. So this is the remote IP. This is another node. And then this is on the other node, as you can see from the IP. This is the tunnel endpoint IP. And I have created a link for this tunnel. And then I will capture traffic on this tunnel device. Then let me send a SMP request. I have sent 3 SMP requests. And then, as you can see, now I can receive the exactly same traffic on another node received on the tunnel device. Of course, we can also receive it on the physical, the physical interface directly, but it's encapsulated. This is the 3 new packets we received. And also, we can have I also create a local port which can receive the traffic, mirror traffic. So this is running on the same node as the source and the destination port. When I ping the destination, I can receive the same traffic on the local mirror port. So because in the demo, I only mirror a single direction. So we only see the outgoing traffic, not the incoming traffic. Okay, that's the demo. And the current plan is we want to support all directions, including ingress, egress, and both, and all actions, including mirror and redirect. And we want to support the listed traffic destinations, such as local port, Westland, Jining, Jiayi, and Yaspan destinations. And in this version, we just want to make it basically work. So we will not do some fine-grained traffic filtering. In next release, we will support traffic filters like based on protocol, port, or IP address. Yeah, that's the current plan. And I also have some open questions. First is about the API name. Currently, I name it traffic control, but I think maybe it's too large for what the API actually does, because in Linux, traffic control tool can do many things. Mirror and traffic is only one feature of it. So another proposal I have is call it mirrored. It's corresponding to TC mirrored function. Or maybe we could use two different APIs for mirroring and redirecting separately, so that this object API name can be more specific for its purpose. And another question is about what should we do for directions, whether the traffic, whether we should treat it in stateful way, meaning that when direction is ingress, should it cover incoming traffic only, or should it cover the outgoing response traffic for this incoming traffic, which is similar to network policies, or we should just treat it as stateless. When it is in ingress, we only mirror or redirect incoming traffic, and the user need to specify both if we want to get the corresponding response traffic. Yeah, and happy to discuss these options here and hear your opinions. And that's almost all for my part. And is there any questions?
Sean, I don't have a good option about name, but I just think that we should not use something which maps a specific utility, or maybe not something that is mapped to TC mirrored, mostly because most people don't even know what it is. But something like traffic controller perhaps is kind of nice. Then, you know, naming, everyone can have a different opinion. The other question is, I looked at the design, looks really cool, but my question is, in Antrea end-to-end testing, how we are going to validate, in your opinion, this functionality in the CI?
Yes, I think it's doable. For validation, for example, to validate the mirror feature, we just need to run a remote. For this can even be a Kubernetes node we are managing, the CI is managing, and it could we could capture traffic or just count the packet number of specific interface to see whether it received the traffic it mirrored.
Okay, and that net, for instance, something that counts, this thing that counts the packet, it's not some piece of software that we have to develop. We can use some existing utility and we get that pretty much for free, right?
Yeah.
Cool. Thanks.
And for redirecting, I think maybe Sam, we could create such object in a test, and then we just use a OS pair device to connect this two interfaces. Then the original packet will still go back to the OS pipeline directly without being dropped. Then we can count whether the number of the packets are same as the number of the traffic between the two ports.
Okay, understood. Thanks.
Yeah, I think later when you add a filter, then sounds like you should do stateful, right? Otherwise, the filter is a little hard to manage.
You mean when a a protocol port number is specified, like
yes. For example,
yeah.
you say a TCP some TCP that's import 80.
I'm not sure how the traditional span function handle this scenario, but
No,
one way.
I think
Yeah.
the span typically it's stateless. That's my understanding. It's more like a switching feature.
Okay.
And actually, I think the stateless one has some benefits too. I mean, if you just look at switch, the performance can be better. I'm not sure it might match our. I mean, does that matter in our case or not? Do you think if we do stateless, the performance can be better?
I think so, because currently, even to support state 4, we need some actual status to be stored in connection track. Otherwise, we don't know whether this is response traffic. If we only need to support stateless, I think we don't need to store anything in CT.
Okay.
To resolve the problem of the use case when port number is specified, I think user can still say that the direction should be both. And when it is both and the port number, for example, 80 is specified, we just check whether it exists in either direction.
Yeah, probably that makes sense. Okay. Now, question for redirection. No, not redirection. For the internal port case, let me see. For the internal port case, why do you think we should auto create the internal port? I think if it's an internal port, likely should be managed by some other solution consume the traffic, right?
You assume the other solution or the other application will mount OpenWSwitch resources and create the port by themselves.
No, for example, in your case, I mean, even you create a port, the other solution need to know about the port. You're saying that since they
should give the name, right? So they can listen to the name.
I think it's probably for mirroring it's clear, but for the redirect case, you have a peer port. You're saying that port is created by who? It's created by the.
It's also this attribute will determine whether we will create the two devices. If it's internal, we just create two internal ports. If it's not internal, we assume the two devices already exist.
Okay. Got it. Another one that for for tunnel, actually people don't really care about the name of the tunnel port, right?
Yes. It is to keep the unique. For example, the scenario that multiple. Yeah. You make sense. But shouldn't we have a name, or we just create a random name?
Okay, probably I need some time to think through.
I think a name is still good, because if they do have multiple policies and they want to share, at least using same name and specifying same arguments can avoid multiple ports in single bridge.
Yeah, I think for internal ports, it's easier to understand since it's really a port. So it should have a name. For tunnel
also maps to OS port.
Yeah, I know, but again, I just mean from consumer perspective, it's a little strange. Why I need to specify a name for my tunnel port?
Kind of.
And I need to understand all the port under OS to avoid any conflicts.
Yeah, maybe that depends whether our documents will be clear for that. If user just follow the documents, the guide, and they should understand this name. For example, for Kubernetes port, you will also need a volume name. Actually, the volume name is only used to identify the volume when you use it.
But that volume name needs to be identical across ports, right? In your case, actually you actually have a requirement of everyone share the same tunnel, must share the same name.
Yeah, in that case, I was going to ask the question: have we entertained the option of having the destination as a separate CRD itself? I mean, I feel like there's enough information for it to be a standalone resource. And then if we're talking about some tunnel, we can definitely just define a CRD just referring to this is a destination created for this tunnel, and the other resources can just refer to it by name, just like the cluster group.
Yeah, yes, I agree. I actually thought about it. Yeah, I think it's just two ways how we present, how we avoid conflict, and how we present the APIs to user. I think that is acceptable. Yeah. We could discuss.
For tunnel in theory, if you want, you can also use flow-based tunnel, right?
I'm not quite sure, because when we set the when we output the package, if we want to output the package to the original tunnel and another tunnel, there is only single tunnel metadata, right? When using flow-based tunnel, we need to set the remote IP to the tunnel metadata. Then I'm not sure whether it works if we want to outputting the package to two devices. Both of them have no remote IP specified. So in my test, I specified the older. I'm not sure whether the approach you mentioned works.
Okay, I think I got it. Okay, probably let's think about it a little. Yeah, I just feel it's a little inconsistent between different types, and even for mirror and the redirect, it's a little inconsistent. I mean, you have a peer name inside the port traffic destination, but the name is outside the is in the directly under the traffic destination struct. Yeah, for the, I think these are minor things. Probably we can discuss offline.
Yeah. Okay.
No.
So there are no other questions. Otto,
Yeah.
and yeah.
Is there no other question for me? Any other question from the community? I guess we can interpret this silence as a no. I guess, I mean, I think this was a great presentation, great new addition to Antrea features. Really looking forward to see it in the first, in Antrea 1.7, according to the roadmap that Chan listed today. So thanks a lot for this presentation, Chan. And I guess this is also all for today, unless anyone has something else to bring up before we finish the call. I'll just wait 10 seconds to see if anyone has anything you'd like to discuss in this last 2 minutes. Perfect. It seems that therefore it's all for today. So thanks everyone for joining, and we'll meet again in 2 weeks' time on Tuesday, April the 26th. Thanks again for joining, and I wish everyone a good evening, a good morning, or a good afternoon.
Thank you.